Safe Software is pleased to present the 2009 FME International User Conference. This session is presented by Hans van der Merel, the owner of Red Geographics. Hans is a longtime FME user and a certified FME professional. Most of Hans's work focuses on bridging the gap between GIS and cartography.
So today I'm going to talk to you about a project that I'm currently involved in. It's about cross-border processing with FME. I'm just going to skip over this quickly because Marcel already mentioned most of it. So I founded my own company in 2004. I've been using FME since 1999. My main areas of work are data manipulation, so FME work, and visualization. Deep down inside, I'm a cartographer. That's why I got involved in the whole geo business. I'm an FME reseller and I'm an FME certified professional. And the project that I'll be describing today is the development of an interactive website for the Rijn-Schelde Delta. This website will allow foreign industrials, like big companies, big businesses, to find suitable locations for settling their European subsidiaries. And there's some interesting problems with this project in that it's a cross-border area. So half of the project area is in the Netherlands and half of it is in Belgium. And this brings some very interesting things. So the area of interest is, as you can see here, it's roughly the area between The Hague and Brussels. And I think it actually goes a bit further east than what's shown here at the moment. And basically the Rijn-Schelde Delta is the delta area of the Rhine and the Scheldt rivers. And it's an organization, the RSD, that promotes cooperative efforts between those, between public and private enterprises in that areas. The main reason behind the website development that I've been involved with is basically convincing foreign businesses to settle their European subsidiaries in that area rather than in Hamburg or Le Havre or somewhere else. So I've sometimes described it as a real estate website for people who want to put factories somewhere. This RSD organization is sort of a cooperative effort. There's a lot of partner organizations underneath it, which involve 2 national governments. Actually, it's the Netherlands and Flanders, which is subnational in Belgium. 6 provincial governments, 13 municipalities, 7 port authorities, 3 chambers of commerce, 3 environmental organizations, the Benelux and the European Union. Fortunately, we all speak the same language. Thank you. And on the site that actually does the website, it's me, another freelance cartographer, and a small business doing the web development. So on one side there's this huge organization, and on the other side it's basically 3 or 4 guys actually doing it. So for the geodata that's involved in this project, we basically had 2 different types. We had topographic data for the base map that I showed a few slides back. So that's basically all the topographic data. There we go. And then we had contours of industrial terrains and additional attribute data. Again, this concept of an industrial terrain is a bit hard to grasp sometimes. It's basically part of or an entire industrial development area. And one of the things we actually figured out in the course of the project is that between the Netherlands and Belgium there's different interpretations of what might constitute an industrial terrain. So obviously both of those types of geodata, we saw heavy use of FME in processing it for the eventual website. And the process in very short boils down to taking both the topographic data and the industrial terrains, creating a base map in Adobe Illustrator, which I've shown, Producing a Google Maps tile set out of that. So we take the Illustrator file, rasterize it, make it a GeoTIFF, run it through Global Mapper, and then it spits out a Google Maps tile set in different zoom levels with all of the HTML that you need. So that's one part. The other part is the industrial terrains, which then go into a database which contains all of the attribute data and a text geometry string, a WKT string. And that's then used to display vector data on top of that Google Map tile set of the base map. And of course the vector data is clickable and selectable. And I've got some screenshots of the whole thing later on. So the topographic data that we used, after some debating, we settled on the 1 in 250,000 scale digital data sets supplied by the TDK, which is the Dutch Topographic Service, and the NGI, their Belgian counterparts. The reason we picked those two data sets as opposed to other data sets that might cover the entire area in a single data model is that there aren't really a whole lot of other data sets covering that entire area in a single data model. And the ones that there are either very expensive, I mean you're talking about NAVTEC or TeleAtlas, or they're not really that good. And I already had a lot of experience using the Dutch 250K data, so we settled on that one also because all of the provincial governments involved in the RSD organization have existing contracts with the respective topographic services. The problem was, though, that there's two different projections used for the data. There's obviously two different sets of accuracy guidelines, because both are actually generalized from more detailed data sets, and there's two different data models. And obviously we only wanted to get one single base map out of it. So that took quite a bit of work. What we did was take the Dutch 1 in 250K dataset, clip it to the border. One of the quirky things about the Dutch topographic data is that it's supplied in map sheets, which are rectangular. So the Dutch datasets actually do cover a fair bit of Belgium. Unfortunately, not enough for this project. So we clip those to the border. We take the Belgian 1 in 250K dataset, which ends at the border, and reproject that to the same projection as the Dutch data. Then we reclassify both datasets into a single new data model. We do a bit of cleanup. I'll go into that a bit later on. And then we output and do some manual corrections just to make the map look nice. So the reclassification, that was the one thing that's been causing us a lot of headaches. And it's not just because it's two different data models, but it's also two very different concepts behind the data model. The Dutch topographic data model is purely topographic. So they would say it's a 4-lane road with a central divider. Whereas the Belgian model is partly thematic. They would say it's a highway, which would be much more useful because the Dutch, if you take all of the Dutch road classifications, you end up with about 150 different ones, which is a lot of work to make any sense out of it. So, as I said, we decided upon a totally new data model and just reclassified both original data sets into that new model. That mapping was done through a single reclassification table in Excel. Here's a quick sample of it. So the first two lines are Belgian attributes describing railways. The bottom two are Dutch attributes describing a railway. Notice that the Dutch are only interested in how it looks, so if it's 1 track or 2 tracks or 4 tracks or electrified or not, whereas the Belgians are more interested in what it's used for. So whether it's a general railway or industrial railway, a high-speed railway, and so on. Again, I'm not really making a judgment on which is better, although I have to say I'm very impressed with the Belgian data after having used the Dutch data so much. I mean, just a sidetrack here, just taking all of the railroads in the Netherlands which are used for passenger transport based on their data model is impossible. There's absolutely no way that it can be done. Whereas in Belgium, it is possible. So after reclassification, we again looked at the data set and we started seeing some very interesting things. One of them was that the Belgian data sets don't actually cover everything. You see these huge wide gaps here. For those who are not familiar with the area, the border runs around here through the river, across, and then up. So the Netherlands is at the top, Belgium is at the bottom. And apparently, at least I haven't been able to find it, apparently in Belgium there is no other category. Fortunately, this can be solved by just putting one single color layer underneath in the mapping application. But it's an interesting concept. Another thing that you may notice is the straight north-south line. That's a Dutch map sheet boundary. So this came out of two different ArcInfo files. If we go a bit more in detail, again, here's the border running up like that. What you'll notice is that there's some minor shifts at the boundary. We're not really sure what's going on there, whether it's a coordinate system problem or whether it's something that's maybe related to the accuracy guidelines, if it's something that we should be worried about, if it's something that can be expected. We decided to simply not worry about it and manually correct it because the data sets aren't updated more than once every 4 years anyway. Other things we noticed was that the Scheldt is a tidal river, and obviously parts of it are dry at low tide, or, well, not exactly dry, but soggy instead of soaking wet. So the Belgian data actually shows those areas which show up at low tide, whereas in the Netherlands at 250,000 scale, they don't. So again, the concept of what is water is different. So all these little quirky problems took a long time to figure out and to solve. As I'm sure you can imagine with road classifications, again, the idea of what is a major road may differ. And of course, we had to make sure that we had no roads on the map that would suddenly end at the border. So moving on to the industrial terrain data. In the Netherlands, this is collected by a single governmental organization, which is being updated once every year, and it comes with a lot of attributes. In Belgium, it's not collected yet. Work on that started this January. It was going to be done by every province. There's 3 of them involved in this. Every province would do that independently. The results are not available yet. Actually, that's not true. This morning I received an email that the data for the province of Antwerpen came in, and whether I could please check it to see if it matched our demands. So hopefully we get some progress here. Again, we tried to get all of this data into a single data model, but there's again differences in concepts and regulations that may prevent this. We had a meeting with the representatives of the 3 Belgian provinces back in January, and we were explaining the data model of the Dutch data, hoping that we'd be able to just take the Belgian data, put it into that model, and be done with it, because they didn't have anything yet. And we came to discuss points like environmental impact categories. In the Netherlands is a number between 1 and 5, 1 being not that bad, 5 being bubbling chemicals. So we explained that to the Belgian people, and they said, well, yeah, we do that differently. We use other categories, we use another classification system. So at the moment, we're not really sure yet how we're going to handle that. Those attributes that I mentioned, and this is at the moment just covering the Dutch data. There's some attributes that are available in the source data, which include how many acres are available for purchase or rent within one single area, how big is the largest individual section that's available for purchase or rent, what's the environmental restrictions on there. Obviously you can't put heavy industry right next to a town. What's the availability of infrastructure? Can you actually get a boat in there to unload stuff? Can you get a train in there? There's some other attributes that we ended up having to calculate. So, for example, what's the distance to the nearest airport, to the nearest train station, to the nearest highway exit, and so on. And this is the monster of the workbench that's doing all of that work. Obviously, this won't fit any best standards, I think, although I did my best. I'm just going to go and discuss a couple of sections in here in detail. So first I'm going to talk about this part here. We've got the industrial terrains coming in here, and in order to calculate distances, again, this is something we had endless discussions about. We decided to calculate that based upon the center point of that area. One area may be 10 by 10 kilometers, well, generally a bit smaller, but they may be fairly large areas. And obviously it's difficult to calculate distances if you have the areas that large to deal with. So we decided to do that based upon the center point and basically calculate using neighbor finders the distances to high-speed train stations, airports, highway exits. Those are all going to be rounded to the nearest 5 kilometers anyway, so it's not as if we need sub-meter accuracy on them. Another part that the RSD came up with fairly late in the project actually was that for every industrial area they wanted to know how far it was from any of the 8 major port areas defined within the project area. So we got those coming in here as a shapefile and a grand total of 8 neighbor finders to do those calculations. And those are being done based upon the distance from the center point of an industrial area to the nearest point on the border of any of those port areas. Now obviously if your industrial area is within one of your port areas, you don't want the distance to be 5 kilometers. So there's a lot of testing going on to find out if an industrial area is within a port area, and if that's the case, set that particular distance to 0. Again, it's I think it's an effect of working on a project that's the client still hasn't made up their mind yet. I think that's what I was trying to say. So the final output that we're getting out of this whole thing is a shapefile that we can import into Adobe Illustrator on top of our base map, so that we can actually produce the base map, because another quirky part about the Dutch Topographic Service is that they don't actually have an area classification industrial terrain. To them it's just built up area. So we had to get those onto the base map. Second part is we write an Excel file with an OGC WKT string, which is a geometry text description of the geometry of a feature. That can be used to display those industrial areas clickable and selectable on the Google Maps tileset. And the final base map is rasterized and exported as a Google Maps tileset using Global Mapper. I haven't tried that with FME yet. As far as I know, there's no standard option to do a Google Maps tileset through FME, although according to Dimitri, it's possible to do a Bing map tileset. So to wrap up, just a couple of screenshots showing what the concept of the online portal is looking like at the moment. This is still heavily work in development, and it may end up looking very different. But this is what your rich Texan oil baron would see if he's going to select an area to put his new refinery in. Over on the right side, you can select a number of criteria that you're looking for. So the size of the area can be specified, whether there's any environmental restrictions, whether or not it's close to a highway or a railway or any of those attributes I mentioned before. And then as you make more and more selections and you start zooming in, the individual areas are being read from that Excel file and being shown on top of the Google Maps tile set. And of course, once you've selected one of those areas, you can get all the attribute data again coming out of that Excel file. The actual goal of this whole web interface is not so much to actually sell a bit of property on an industrial terrain. It's more to get people interested and to get them in touch with the right port authorities who can get them through the process of actually purchasing or renting the terrain. So it's not entirely real estate website, but it's getting pretty close to it. One thing you'll notice if you look closely is that there is a bit of shifting going on between the raster data and the vector data. We're not entirely sure what that is yet. We think it's probably related to the fact that I used the Mercator projector instead of the Google Mercator projection. But we're hopefully tackling that in a couple of weeks. So the most important lessons that at least I've learned from this project is that different data models, especially if they're coming from different countries, are really difficult to overcome. And coordinate system problems can be a terrible headache, basically. Especially in the case with the Belgian data, because at the moment they've got apparently 3 possible projections that can be used. I see the one Belgian person in the room going wide-eyed. Well, the bad part was that it wasn't even entirely obvious which projection was used. But there's Lambert 1972, 2005, and 2008. And we got files without any metadata saying what it was. So we ended up finding one that, when we compared it to the Dutch data, came really close to it. So we said, this is probably the one that we need. And then again, we manually corrected any gaps and mistakes. So that's about wraps it up for what I had to say. My pleasure.